Bonjour tout le monde. Je vais faire la présentation en anglais. I'll do the presentation in English. I know it's the last presentation, so I'm very pleased to see a lot of you. I know many of you for being in the industry for quite a while now. Just before we start, I would like to, what I'm going to present, it's not something done by one person. There's a big team behind it, and there's a few people in the crowd today that are with FPInnovations. So, William, if you could stand up. Jean, please. Where's Eric? Eric. Bonjour, Eric. Who am I missing, là? And Simba aussi. Sorry, Simba, the light. C'est bon. Thank you. And in Simba also. There are people located either in Montreal or Quebec, and they've been working very heavily on the presentation I'm going to do today. The overall objective today of the presentation is to give you an highlight survey, an overview of what is SM2, SM2 S for smart, M for manufacturing. Second at the exponent, to go faster. So mainly that's what we're going to look at. And what I would like to present to you is a toolbox of what we're working on to really try to prepare the industry for the 21st century, where we're going to need much more agile and flexible operation and much more intelligent. First, for those who don't know FPI, very quickly, we have over 425 employees. We have a budget of $75 million. We're mainly covering 4 sectors of activities innovation: the wood sector, the forest operation, the pulp and paper, and also just what is a year, 2 years ago, the bio sector. It's about what, a year now? 2 years now? Okay, thank you. And you probably heard, some of you, that Quebec office is moving. We're staying in Quebec. We're refocusing our activities in a few segments, but more focus on it. And we're going to move close to the Laval University to try to share more the assets over there. There was a lot of duplication in terms of assets, and we're trying to manage that different way, like a little bit like you guys with your mills, where sometimes you're trying to manage assets differently. And also, we're trying to leverage more with expertise from Laval to try to accelerate some of the work by making more partnership. And just with the initiative and the change, we just hired since September last year 7 new people that are working around that environment. So that will bring roughly 55 people in Quebec in 3 areas. Some will be located at Laval University, at the Centre Forestier Laurentide, just across Laval University, and some will remain in the old 319 where we used to be. Originally, the initiative took its origin in Quebec and Ontario. We're going back to roughly 2010, where some people, there was that slump in the production, and even at that time, a lot of people were questioning what would happen with the economy bringing back and producing more, like what we're going to do with the chips and all this. So it really originated in the Quebec and Ontario area, but there's a lot of activities we're doing that will very help the rest of the industry across Canada. And on the slide, you can see 7 bars. Those are the average variable production cost of 7 regions in North America. Taller the bar, more the variable cost is high. And below the 0 line, you can see like a yellow or orange portion. This is the co-products. And if you subtract the co-products, the yellow part, from the green part, which is the wood cost, it creates the dotted line, which is the average variable cost net of the wood cost. As you can see, there's 4 regions that are pretty much about the same in 2016 in terms of cost. But the bad news about it is, like in Quebec and Ontario, all our business model was relying a lot on the chip revenues and all the other co-products. That's why you see that yellow portion is higher. Since 2005, there's about 30 machines across the East that have shut down. So there's 30 machines of paper for co-products that are still there. And we need to find ways to improve our process, more recovery, and try to diversify. We're going to still make some chips, sawdust and shavings, but we need to find new homes for it. So mainly, the goal is to reduce the amount, produce less chips. The second thing, if you produce less chips, you're going to have more lumber, more products out of it. You need to find new homes for those. So we need to look at diversifying the products. And the same thing for the co-products. If the co-products are reduced and we can afford in our business model and financial model a price set lower for other type of application that may find a new home, at the same time, it must not affect your profitability, of course. And of course, in the East and the West, there's been a lot of change in the resource. For many years out West, the pine beetle was the flavor of the day in terms of producing around that. And there's a change in that, so the industry over there is more and more reintroducing things like fur. Same thing in Quebec, the proportion of fur is going up. So we need to address those new species. They used to be there, but the volume is much higher. Find new ways to operate with those efficiently. And of course, for everybody, it's to maximize the value based on the higher delivered across Canada. One of the major things that we see across all operation, and it's not only in the forest operation, it's not something new for you, is the skilled manpower shortage. Okay, the solid wood sector, it's unfortunate, but when you produce news like we used to see for 10, 15, 20 years, where there's the crisis with the SLA lumber, mills are shutting down, not very good news to attract new people in the mills. And also, more in the East, the traditional investment based solely on the traditional KPIs like productivity, recovery. When you start to do your math in the East, it's very hard to justify 10, 15, $20 million of line. And people are focusing more and more and trying to tweak their existing operations and to be able to max out the revenues. All the major investments, nothing new for you guys. It's in southern US. There's been even a slowdown out west in terms of investment. So just based on that, it's hard to justify. Is there other ways to be able to justify investment that would change the way to operate? And also, there's a strong desire among yourself to find new homes for lumber and find new homes for your co-products. Also, another thing that is changing a lot is the, sorry about that. It's the operational excellence. When you start to look at KPIs across all the mills in Canada, you compare individual companies, you compare within that company the many mills, you see a very large range of operational excellence, range in process parameters values. Like just as an example, the recovery factor in Quebec, the best mill around 3.2 cubic meters per 1,000 board feet, and the worst mill are at 5. And yes, some of it is explained by the business model that are in, but also a lot of it is explained by the way the mills are being operated. And with the shortage and the disappearance of a lot of skilled people, you will have more competency disappearing with time. So is there any ways to introduce new technologies to help the people that are there and try to retain some of that skill in some of the way to operate? The smart manufacturing mission is really in sync with the 21st centuries. We all have phones, iPhones in our pockets, And if everybody would pick it out, I would bet there's not were maybe, what, 15, 20 people here. There will not be like 5 iPhones or that are really the same. People are buying different stuff to differentiate themselves from the others. And this is going to happen to the sawmilling industry down the road. Everybody, just look at the products that you make. You make a premium. A company will call it a premium plus. Another one will be a stud plus. Another one will be a superior grade. They're all the same with that little difference to be able to sell it to Home Depot, to Lowe's, to whatever. But when you translate that in the mill operation in your sawmill, and you need to adjust your optimizers to produce that order, and the next day it's for a next order, it does introduce variability in your process, and it does impact a lot on your skilled people to be able to handle all that. And down the road, it won't be to produce carloads of products. We need to focus to get our mills to be able to produce half a carload, half a truck at the speed of the commodity. SM2 is going in that direction. That's what we're trying to do. We cannot do that alone at FPI. So the best way is to work with partners. So you will see some example where all the projects we have either commercial partners to deliver the solution. Some of it we need to go back to universities to look at some of the options or opportunities. There's a list of partners, and that's the only way you're going to be able to accelerate. In SM2, instead of investing a small amount for the next 10 years in something, we have decided to really plunge in it. Our members is supporting us financially very high. We have other partners as well in terms of OEM that are investing into it, where we're investing massive amount to be able to attract expertise and to deliver much more faster work. What I'm going to present to you today is not a new sawmill. You already have sawmills that you operate. We're providing you a set of tools, a toolbox of technologies, of opportunities in terms of products development, an opportunity in terms of really game-changing stuff. You're going to hear stuff. I'm probably going to see some laugh in the crowd, but I'm sure it's going to happen. A toolbox so you can adapt that toolbox to what you need in your mill. So you don't need to say, I need to implement all this. You might need some features. It's really not a new configuration of sawmill. That's not what we're looking at today. Our program of work in the initiative looks over all the sawmill area, the planer mill, and the dryer itself. What's in blue, it's advanced intelligent vision systems. We're looking at new type of sensors. If you want to be able to control and provide retroactions to equipment to get them much more smarter, you need to provide more data. There are some data, but most data that you will find in a mill today relies on geometry. Some of the project we're looking at, we're going to go in the log and also to look at the condition of the log being processed. That may trigger better control on some of the aspect of the mill. There's also, if you have more visions and you combine them together with artificial intelligence, machine learning stuff, you'll be able to develop what we call much more smarter platform. I don't know if I should say that. I will. Some equipment out there, they're more stupid than a photocopier right now. Just look at a photocopier when there's a jam of paper in it. Now it tells you which drawer to open, when to change the tone, things like that. It's unfortunate. We have a lot of machine out there with a lot of data, but the data is not processed. It's not used properly to be able to say, hey, you know what? I've been screwing my boards for the last hour. I should auto-adjust myself a certain way. So we're going to review three groups of R&D activities we're working on. The first one is advanced vision. we're going to look at a few smart platform and 3 game-breaking technologies, and I'm going to give a blink on some examples of new product development we're looking at. So if we start at the entrance of the mill, j'espère que ça va marcher. Yes. First thing is automatic vision of a species. When we have a log or a tree going in a mill, a lot of you guys knows that when we process spruce versus balsam fir versus jack pine, if we could auto-adjust the debarker when it comes in, know what temperature it is, know what moisture content it is, and send that information to a smart system, you'll be able to adjust the debarker. I didn't bring my telephone. Laval University developed a technology based on machine learning. They took 2,000 trees on the campus at Laval, looking at bark. And they processed that in a what they call a deep learning algorithm. I think it's a technology that allows the system to train with some basic data and be able to identify 18 species 94.5% of the time. And they've done that in a lab to accelerate the work. They're working with us, and we're going to try that in the mill. And that's going to happen over the next summer for some aspect of it. The system is so good, maybe some of you are very experienced, it can identify black spruce, red spruce, and white spruce with the bark, which I can't do, which is a good system. Of course, there's all kind of things to think about, but this is really a nice vision system that could be installed in a platform that we'll discuss a little bit later on. The next one, a lot of people have been looking at, can we position our cutting tools in a log so we can, when we cut the tree, we rotate the log, we can position the knots on the face better than the edge to get better properties, better values. So FPI has been working for 4 years now on a technology which is based on medical image to be able to identify the defects and features in a log. To be able to say if you could rotate it a certain way or position your saws a certain way, I would get much more higher value. The challenge is to come up with a technology at a relatively lower price so it can be afforded for the sawmill and try to aim at a payback of 1.5 to 2 years. To be able to do that, FPI has decided to do what we call a strategic research alliance with 3 OEMs that I cannot mention today, but 3 major equipment manufacturers that are working with us to the development of that technology. A lot of vision systems are used in the sawmill that indirectly give results. Like, I'll give you an example. There's those scanners that measure, optimize, and define what angle the rotation of a log should be before it's being cut. And down the road, the same type of scanners is used to try to say, I ask for 15 degrees and I have 5 degrees, so there's a difference of between the set points and the actual value of 10 degrees. There's a lot of money on controlling aspect, but the measurement is still indirect. We've been approached by ScanMeg, and they have developed a technology that can measure directly the log rotation on the log. And with the previous technology, which is around the rotation for the CT scanner, this could be a good combination of stuff. Or just with your existing system in the mills, have a better control of the angle of what you're trying to achieve. I'll show you some data of the difference between what the set points are on average for a mill that was followed for a year a little bit later on. The next technology we're looking at, it's species identification, no more on the logs, but at the lumber, at the green and the dry process. A lot of you guys do have weight scale, which give you a measurement of the weight. So if you have a heavy balsam fir, you're going to put it in one sort. If you have a low balsam fir, you may put it with an heavier spruce, those type of things, to try to manage your sorting strategy before the kilns. This gives a good improvement, but if we could identify on the line directly the species, there's a potential uplift in your drying productivity of 28% by doing this, which is tremendous. We have developed a technology at FPI. We have licensed it to a commercial partner, in this case is Autolog, and we're working for them to finalize the calibration and the commercialization for a real-world environment. And our partner at the mill to test it is GDS that will be testing it for the dry first, and after that we're going to work on the green version for the before the kilns. Many of you have at the planer scanner system that measure the moisture. Unfortunately, moisture is very heavily influenced by temperature. During winter, you need to recalibrate, the precision goes down and all this. We've been working with a company, SCS, to be able to auto-calibrate it by measuring certain attributes and not only the temperature. So if you look at the graph at the top, this would be the values, the light green that are measured by the two-pin system versus the other one, and we needed to calibrate all this. So we have started to develop intelligent equations to be able to match both, so which is the graph. If you have more precisions, you're going to get much more higher value out of your wood, things like that. The other thing also is traceability of the lumber and the logs in the mill. ScanMeg has developed a technology where it's like a fingerprint technology. They have 6 or 7 criteria, like you do for fingerprinting identification, and they're using this to be able to say, even if it's going back in a bundle and things like that, that piece, I know where it comes from in the mill. It's come from the edger, and I see Wayne more on the left side or the right side, and now I can tell you that you need to go back to your machine to adjust. That's step 1, to tell someone to go there. Step 2 will say, hey, I see that for the last 15 boards. I see that skew, adjust it automatically. Down the road, we're not there today. But those type of technologies will allow to do that type of intervention. Now, if we have a sensor for temperature, a sensor for moisture, a sensor for the species, I'm just in front of the debarker, I can send all that information and adjust my debarker pressure roll, feed speed, rotational roll, and do a much more better debarking than what we used to do. And to be able to do that, you don't want to just develop equations. There are technologies out there that look at the outfeed, and they can combine what's coming out in terms of vision with what's going in, and have a much more smarter technology right there. The other one, we've been working with one sawmill, and we monitor 2.6 million logs in a year in all the conditions. Summertime, wintertime, and we followed what was the difference between the set point from the scanner and what happened in terms of rotation of the log. And the middle graph, it's not very clear. It shows how it moved during the year. And from January to April, the machine improved by itself. Nobody touched it. So everybody says, oh, it is just the temperature. It's frozen wood. But when you start to dig in it, They are the source of variation that needs to be looked at to be able to explain. So we're taking that log turner, we're going to plug all kind of equipments like a patient at the hospital, and we're going to start to monitor to see where truly the variation is. Because when you buy those technologies, the manufacturer will tell you that you should not have an error of more than 7.5 degrees. 7.5 degrees, that's the bar that you can see on the second graph, but look how many times during the year it's above that bar. But it's explained by maybe mechanical, maybe electronic. Monday morning, the system is not working as good as Tuesday afternoon. Everybody says, hydraulic unit, not heat enough. Are you sure? We need to look into that. The goal of this, collect data, find the source of variation, and put a smart platform on it to guide the people for the maintenance and down the road for a real-time adaptive system. Just to give you an idea, on average, we've done over 20 studies in Eastern Canada on log turners, and on average, the saving to have a better control is between $250,000 to $500,000, depending on the size of the mill. So we can put some effort into that. The next one, that's my favorite one. How much of you have watched the movie, the owner of McDonald's, the founder? Probably a lot of you guys. Remember when they are in the parking lot and they're drawing on the asphalt all the, and they're trying to make that hamburger in what, 30 seconds? Just look at the saw filing room. You go there, it's saws that's worth maybe $150 to $250 each. That goes in a machine that costs $1.5 million. And you ask the saw filers, sometimes there's 3, 4, 5, how do you do that? They have all their own recipes. Me, Serge, I check it like that and process. It's strange to say that. We're in 2018. What we're looking at with this project is to create a McDonald's in that saw filing room and push it. Because when you put those saws, they don't behave the same thing in summertime than in wintertime, frozen wood. So from each saw, we want to know in what condition of operation it was. We want to retroact that information to the saw that is in the saw filing room to be able to say, you know what, that saw today, 8,000 log in that condition, it's in certain format. Of course, there's a lot of technologies out there, like Volmer, things like that, that say that they have that mini robot. None of them does the diagnostic. So us at FPI, we're expert in that, and we're going to be supported by specialists in robots and industrial visions to be able to finalize, not to finalize, to provide additional information, so all the saws, when they go back in the field, they're always all the same. If they start to be always all the same, the curve is going to reduce. You talk with specialists out there, most of the mills are between 125 and 145 thick curve. How come there's some guys at 600, 650 feet a minute today, they're at 105? And when we talk to them, we could be at 195, Serge, if we have that extra little thing to play with. But it's a lot of money. And that's an area we're going to put a lot of effort over the next 2 years. Planer settings. Another area where we can have a platform. In this case, it's Les Produits Gilbert has approached us about a year ago to work with them to a self-automatic planer. What do we mean by this? When you change your heads, your circle of cut change. You put that in. Currently, the operators pass 15, 20 boards, starts to make adjustments. He goes away, the wood change at the infeed, thinner, thicker, you lose money. So we want to measure what's coming in, see what's coming out, and even measure the heads, how they play, because sometimes you put that honing on it, so the circle, the cutting circle change, to have a full retroaction system on it. Why it's important? Today you're probably making 50 different type of products. In 4 or 5 years, a lot of you will make 200, 250. Do you want to go adjust that for every recipes you have? You should have something that is much more automated. So we'll provide tools to some of you. There seems to be a need in the market. Produits Forestier Gilbert, in that case, is working with us. We cannot do that alone. We're going to work with the Institut National d'Optique in Quebec, and also another group which is specialized in robotic and vision. The project is a 2-year project, and we're starting April 1st on this one. The next one. A lot of mills today are getting much more complex. They're even adding lines in the mill. You have a major line, you have a specialty line, you add another line. Me, I know I can juggle with three balls at the same time. When I start to see a fourth, a fifth, a sixth, I can't. We're asking a lot from our supervisors. This project aims at being able to provide collaboration tool with the guys. When you look into this, you have a different order file that come at the planer as an example. And you have different product customer needs. You also have, in the case where we're going to try this project, a radio frequency planer line. You have kilns that produce either over-dry, under-dry wood. You have grading technologies, auto-grader, grade expert, all this. You want to maximize all that information. You put that on the desk of a guy, forget about it. Sorry, girls, it's my way of talking. You put that on the desk of somebody, it's hard to make sure you optimize the ratio. If you have a special line for specialties, you want to make sure it's fully occupied all the time. That's the type of things we're going to start to play with. So it's massive data to be able to analyze and start to develop their own recipes to max out all the assets that you have. We're looking at a new generation of saw blades. This is a $1.8 million project over 4 years with a mechanical engineer group at Laval University and also a group that is in Trois-Rivières that has been working in all kind of material around airplanes, things like that, to look at the next generation of blades. The goal is 1,000 feet a minute minimum of production with a curve in a bull, as an example, 75, 0.075. It's a huge gap. Okay, there's material out there. There's way to look at it to play with what is the number one enemy in a blade, which is the temperature. So Maybec is working with us. We don't have any OEM yet involved. We're too early in terms of development. So there's a lot of work to be done initially to try to see what is the technology position, and then we'll go to the next step. We have 8 different projects in that group. It's probably not the 8 that will be successful, but if we have 1 or 2 that can bring us down there, which is going to make a big difference for you guys. The next one, it's ultra-fast drying. This is my preferred one. Every time you bring a log in a sawmill, you saw it, you dry it, and you plane it. Normally, it's a week to 2 weeks before you put it on the truck to go to the market. Our goal with this project is to do all this in 6 hours. I know. I know. I'm sure there's some people who like it, because you can start to think, holy shit, do I still need my my bins? Can I connect direct to the planer? Can I do this? Can I do that? This is SM2. Okay? Those type of things we're looking at, it's SM2. Now, are we dreaming? Are they that thick? You know where it comes? It comes from a study in 2011 that FPI worked on, and they were able to demonstrate that 30 minutes jack pine have an inch. I said, oh, what about spruce? 2 hours. Is it twisted? Is it all nice? No. We need to work on that. But that's a big game changer if we can succeed. So we're putting a lot of effort into that. And I saw a lot of those, The next one, the way we work, we do R&D work, and then we're trying to find a partner to do commercial demonstration. This is a project that is currently happening, and in summer 2019, we're going to have a radio frequency beside a planer line to dry specialty products or to dry balsam fir that is too wet, that was not able to get dry, to finish the job parallel to the planer line. So we're very happy to work with, we have like 7 partners into it, and we have the mill, it's going to be it's in Matan, and this is going to happen next summer. And that will be linked with the drying, so you want to make sure that you don't over dry, so your RF is empty, and you don't under dry, and now your RF is full, and it's stopping the planer line. You need to adjust all this, so this is where the smart manufacturing platform comes into play. So, so that's another type of technology we're working on. I forgot a few things, but I'll fix it. Sorry about that. I'm almost done. Okay. Now, we get better at the sawmills. We get better at operation. We produce more material. We still have chips. Can we do something more? Can we increase the market pie? There are another set. There's a third objective in the SM2 project, which is around product and co-product diversification. So I'll show you a few examples of things we're working on. Currently in Quebec, as an example, there's over 200,000 tons of chips on the ground. We don't know what to do with it. Can we find a new home for it? We've been approached by Uniboard, by Louisiana Pacific, and Arbec, which has sawmill close to their site, and they struggle also for raw material and supply. Can we modify some cutting tools in the sawmill and be able to process some of the stuff in our operation? They're working very closely for us. We're not working on the chipping heads, those type of things. There's already people working onto that. There are other things we can look at, and that's what they're doing. And where strength is, you define a new type of shavings or lamella for them. We still need to verify what will be the impact on their process. So that's where we're working. We've done some tests. We sent some wood to Germany in a system, and we're getting it modified and adjusted. Currently, based on the result we received from Uniboard, 77% of the material being processed. It requires a special chipper in your sawmills. It's sent to Uniboard in their regular process. 77% of the material was good for the production. They need 70,000, 20,000 in Quebec and 50,000 in Val-d'Or. That would help a lot the industry. We're not trying to reinvent new equipment, but really modifying it, optimizing it, those type of things. That's an example of we're trying to do something quick for the industry, but at the same time, it will help us diversify the production. The next one, we all know that hardwood, certain species are very hard to impregnate. We hear a lot that we want to build those 18-story high building, we're going to put wood into it. There's not an 18-story high building every corner, but there's fence in a lot of places. There are patio in a lot of places, and we have been losing share of that market because we don't have the right protection of our material. Can we work on that? So we have a project that is looking at how we can improve so we can have any type of chemicals going in it much more easier in the process. So we started this project about 3 months ago. It's a 2-year project, and the team is looking at some novel technology to be able to facilitate the penetration of those products. The other one is interesting. I'm sure you're going to still do that one. We're taking a regular kiln. When you dry the wood, we have decided to inject borat, a salt, in the process, the environment, and that's what's coming out. It's all treated. We're not going to a treated plant. It can be done in a sawmill process. So you can imagine you just save a logistic step and all this. We're still exploring. There's an owner of a patent on this. He has an agreement for licensing it with us. We're working on this technology to fine-tune it, and that's what we're looking. We're looking at two aspects. There's exportation. You don't need to go deep. And also all the red stuff in the south where the termites are. That's what we're looking at. And in his patent, we're going to add something we have figured out to be able to penetrate deeper. We were very close in the past on pine to be able to do it, but we missed the limit, and that's what we're trying to do here. So, a kiln that you already have. The next type of product, it's boards for insulations. Can be all kind of boards. Can be from chips, making special boards. There are some technologies in Europe, okay, that does that. That would be a new home for chips if we can develop that to compete the pink stuff in the wall, the Roxel, the XPS and EPS. That's another project we're looking at. And a very recent one, a company in Canada, Canada Litter, approached us, and they want to develop a niche market with an organic litter for cats. We're not talking millions of tons, but we're still talking between 25 and 30,000 tons a year that could be converted in a product that would have the same properties as for what you find in the bentonite, to be able to absorb le pipi du chat. Sorry. The cat piss, thank you. You cannot imagine, when we sat down with a guy, the set of attributes that he needs to have to make that thing work. It's incredible. May sound simple, but it's incredible. So we're doing an exploratory project, hoping we can do that. It's good, because if we can do it for cats, maybe we can do it for other type of litter, for other type of animal. They are horses. They are cows, those type of things. Can we have something that can protect the animal, releasing some agent for them? Ça veut dire quoi, ça, 5 minutes? Cows? OK. C'est bon, thank you. Oh, Seigneur. Il fallait bien que tu lâches. So, this is another example where we're trying to diversify. But you know what? FPI, our OEMs, even our investees, we cannot do that all by ourselves. You do have a lot of creativity. We're there to support you. Currently, there are 14 projects approved. We have a budget for about 25. Okay? We have engaged roughly 10 million for over the next 1, 2, 3 years, okay, on some of those projects. And we have room for new ideas and for additional development to change that industry. There's some wow, there's some regular stuff, but if we really want to change that industry, there's a lot of creativity. We just need to work together, and we're offering that to our members, we're offering that to the industry. This year, we're going to spend 30,000 hours roughly on research on what you saw today. We have 4 external research institutes, 6 groups that are involved in mechanical engineer, wood processing, artificial intelligence, robotization. Currently, we have 12 commercial partners, OEMs, that are involved on the more ready-to-go project. And there's 8 industry members for the ready-to-go stuff that are going to test it over the next 12 to 18 months. So interested mills and commercial partners, please call if you have ID. We can sit down and work with you guys. And So summarize everything. To be smart and agile, you need two things. You need intelligence. Technologies out there to support this. You do need visions. Like when you taste a wine, red wine, if you pinch your nose, it does not taste the same if you add more sensors to it. It's the same thing in the mill. And this century is the one that will reward the gazelle, the one that will be agile, smart, and very intelligent. If you want to participate, don't hesitate to reach out.